We are Team 1005, Prassanna, Himanshu and Harshit from the University of Delhi. Our coach is Dr. Singh, and this is our solution to problem C of SCUDEM 5 2020. Let's start on a rather philosophical note, keeping in mind that all models are wrong, but some are useful. We begin by presenting our understanding of the given problem. A settlement has different types of refugees based on their choice of conflict resolution strategies. We need to model the population sizes of these groups over time under the assumption that people can move between such groups. First, we will look into the case when the population of the settlement is fixed. Having accomplished that, we will consider the case when refugees from other settlements migrate into this settlement. So the following is our solution to the case 1 of the given problem. We begin with assuming that there is a settlement with a total population of 1500 having 4 different types of refugees divided on the basis of dispute resolution used by them. The mediators believe that someone should act as a guide to help the parties involved find their own solution to which all can agree, while the arbitrators believe that someone should make decisions by which others must abide. The negotiators are expected to negotiate among themselves, and the people in the indifferent category don't believe in any of the above 3 strategies, but are willing to follow one if they are convinced. We assume that the initial population of the mediators, the arbitrators, and the negotiators are 400 each, while that of the indifferent is 300. Now all the followers of each of the first 3 categories also propagate their strategy. In other words, each mediator, arbitrator, and negotiator try to convince others to join their league. For example, the mediators try to convince the arbitrators, the negotiators, and the indifferent to come and join their group. Similarly, the arbitrators try to convince the mediators, the negotiators, and the indifferent, and the negotiators try to convince the arbitrators, the mediators, and the indifferent. Please note that the indifferent don't try to convince anyone, but can very well be convinced to move to a different group. One of the major assumptions our model makes is that a refugee can believe in more than one strategy. Thus, it is quite possible that over time, all the people in the camp start believing in negotiation and arbitration, with no one believing in mediation. Hence, as a result, they might come up with a new strategy for dispute resolution, which incorporates the characteristics of both negotiation and arbitration. Having all this in mind, we can now formulate a set of word equations which can further dictate how our differential equations would look. So the rate of growth in mediators is equal to the rate of non-mediators becoming mediators minus the rate of mediators becoming arbitrators minus the rate of mediators becoming negotiators. Similarly, the rate of growth in arbitrators is equal to the rate of non-arbitrators becoming arbitrators minus the rate of all arbitrators becoming mediators minus the rate of arbitrators becoming negotiators. In the same way, the rate of growth in negotiators can also be formulated. Now coming to the model, for the rate of non-x becoming x term, we began with the basic Verhulst model, more commonly known as the logistic model. It is quite a common practice to use the logistic model in modeling the adoption of some innovation over time. We can compare the resolution strategies with innovations and try to get an idea of how a resolution strategy might get famous over time. So the rate of non-x becoming x can be seen as Rx into x into 1 minus x by p, where x is the population of a specific group and Rx is the inherent per capita growth of x and p is the total population. Coming to the outgoing terms, the basic idea we use is that the rate of people moving from group X to group Y is directly proportional to both the population of X and the ratio of the population of Y to total population. So the rate of X becoming Y is equal to Rx into Txy into X, where X and Y are the population of the two groups. Rx is the inherent per capita growth of X and Txy is the per capita conversion of people in X to Y. P is of course the total population. Now that it's time to finally write our differential equations, we must be clear with the abbreviations we shall be using. We represent the populations of the 3 major groups with mediator of T, arbitrator of T, and negotiator of T respectively. Similarly, RA, Rn, and Rm are the inherent per capita growths of the 3 groups. And the abbreviations on the right denote the per capita conversion of people from one group to another. Hence our final set of differential equations can be written down as follows, and we finally try to solve the given set of differential equations on the Wolfram Mathematica 9.0 system. Please note that all the constants of proportionality had been left open for manipulation while writing down the code, and hence we obtain the following plot. In the given plot, the blue line indicates the population of the mediators, the red line the population of the arbitrators, and the yellow the population of the negotiators. A patient observation yells that for any set of positive constants over time, any two of the three groups merge and their population plummets down to 0. The one remaining converges to 1500, that is, the whole population adopts that strategy. Nevertheless, a rare case can occur where all constants other than TAN and TNA are positive and those two are equal to 0. In such a case, the negotiators and the arbitrators merge and their population converges to 1500. That is the total population. There will be no mediators left, and the complete settlement might as well create a new resolution strategy, incorporating both negotiation and arbitration. And now we come to the second part of the problem. Here we consider the case when new people move into the settlement over time. To model such a case, we make the following assumptions. Initially, there is a settlement with a total population of 700 people, having only 400 negotiators and 300 indifferent. Two new groups of refugees move into the settlement over time, and both groups have population of 400 each. One of the groups has only mediators and the other has only arbitrators. To model the arrival of refugees over time t, we take the idea from the fact that when a local unrest breaks out, instantly people rush to seek refuge. Thus the rate of refuge influx would soar. As time passes, the impact of the unrest recedes and fewer people make new arrivals at the gathering points. Also, it is worth considering that the total number of refugees produced by an unrest is limited. Hence, our model which best describes such growth is clearly of the type x-t is equal to beta e to the power minus beta t by a, where a is the total number of refugees and beta is the initial rate of incoming refugees. Hence, the change in the population of the settlement can be modeled as p-t equal to mu e to the power minus mu t by m naught plus alpha e to the power minus alpha t by a naught, with the initial population equal to 700. Here mu and alpha are the initial rates of incoming mediators and arbitrators respectively. Similarly, m naught and a naught are the total mediators and the arbitrators respectively, that is m naught equal to a naught equal to 400. To avoid complexity in the solutions, we assume alpha equal to mu equal to 4 and then we try to solve the given set of differential equations. On solving these differential equations, we get p of t is equal to 1500 minus 800 e to the power minus t by 100. For a reality check, we plot this equation using the Wolfram Mathematica system, and the plot indeed matches our hypothesis. In formulating the differential equations for this case, the only difference here is that the total population of the settlement is not constant at 1500 and changes over time. As the set of differential equations will be similar to case 1, with the sole difference that 1500 will be replaced by 1500 minus 800 e to the power minus t by 100. Again, we try to solve the given set of differential equations on the Wolfram Mathematica 9.2 system, and following is the plot we get. Another patient observation yields similar results as in the fixed population case. Two of the three groups merge and their population plummets down to 0. The one remaining converges to 1500, that is, the whole population adopts that strategy. Nevertheless, there are quite a few obvious changes, like the changes are quite slow as compared to the previous case and other subtle changes. Just like the previous case, a rare case can occur where all the constants other than TAN and TNA are positive, with those two being equal to 0. In this case, the negotiators and the arbitrators merge and their population converges to 1500, that is the total population. There will be no mediators left and the complete settlement might as well create a new resolution strategy incorporating both negotiation and arbitration. And now it's time for the conclusions. Usually two of the three groups merge and their population plummets down to 0. The one remaining converges to the total population, that is the whole population adopts that strategy. In case of a fixed population, the convergence is quite fast as compared to the case of a growing population. There can be cases when some of the groups have null effect in motivating the others to change their stand. In such situations, we see the population of the two groups converging to the total population and the one left becoming null and void. Then there shall be a high chances of the creation of a new dispute resolution strategy incorporating the ideas of the two winners. Finally, here is the list of references we used to obtain our solution. And to end on a philosophical note, the laws of nature are nothing but the mathematical thoughts of God. Thank you.